So today we're going to take a look at exterior and interior angles of polygons so that we can do some work with these shapes and so on, because they're going to be part of the external. So first thing is, what's an interior and exterior angle? What's a polygon? These are things that should not be news to us. So basically we can talk about this thing here as an exterior angle of a polygon. Right? So, I mean, basically, to create an exterior angle of a polygon, you just extend a line, and then what you've created is an exterior angle of that particular polygon, okay? So, and then there's interior angles. So you need to know the vocabulary. What's an interior? What's an exterior angle? Now, what's a polygon? Well, a polygon is a multi-sided shape that has various sides to it, and it's enclosed. It has to be closed. Right? And you can have two types of polygons. You can have regular polygons or irregular polygons. So a regular polygon just means that it has all equal sides, and an irregular polygon means it doesn't have equal sides. And you need to know the names of these, at least up to 10-sided shapes, so that you can use this and understand it when they ask you about it in an exam. Triangle, 3 sides, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, which is a 9-sided shape, and a decagon. Okay, so you need to know those basic names for the various polygons, and then you have to understand some things about regular polygons. Regular polygons, basically, if we were to mark, the sides, this would be equal to this. We mark them with little dash lines. So all those sides are equal, which means in a regular polygon also that all the angles are also interior, are also equal. Since all the sides are equal, all the angles are equal, and all the exterior angles will be the same size as well. So all sides equal, all angles equal, and so on. And they also have lines of symmetry that we can talk about. But lines of symmetry, remember, mean that you can basically break a shape up into, well, that's not a line of symmetry at all. But if we take a look here, we can break this shape up into, mirror images of itself. So that's a line of symmetry. Often we dot the line as a line of symmetry. So that's one line of symmetry. Can we have another line of symmetry? Sure we can, because we can go from there to there. That's a line of symmetry. So a line of symmetry just means that you can draw a line and then you can just basically fold the shape onto itself, right? So that's what we mean by lines of symmetry. So polygons, name them, know what an exterior and an interior angle of a polygon is, where it's located, and then we need to know some properties about those exterior and interior angles. So exterior angle is pretty simple. No matter what the polygon is, the exterior angles will always, will always add up to these are the exterior angles, right? I don't know what you're doing, but I need you to stop doing it. They will always add up, so we have exterior angles here, 1, 2, 3, 4, 5. They'll always add up to 360 degrees. Okay, now if you don't believe me, this is a nice little animation over here, and if we watch this little animation, we have a shape. Let's just play it. So these are various size shapes, and they have exterior angles, and if we make those shapes smaller and smaller and smaller, you can see that they create basically circles. The angles make a circle, which is 360 degrees. So if we just watch that again, as you shrink these shapes down, they get smaller and smaller, and then those exterior angles create a circle. So we have exterior angles of polygons, no matter what the polygon is going to add to 360 degrees. So that's very important. And so if we need to write that, exterior angles of polygons add to 360. Always. All right? Now they may all be equal depending on whether you have a regular polygon or an irregular polygon. They may not be equal. Now, the other thing that's be very important is this whole interior angles of polygons thing. And you probably would have seen this before. And it all has to do with how we create triangles within these quadrilaterals. So if I just go to Desmos real quick. And let's say I just make a four-sided shape. So I'm going to make a four-sided shape. 1, 2, 3, 4. And I'm just going to make it, undo that. I'm just going to make it, somewhat irregular. I don't want it to be a regular shape of any kind. Now, if I draw a line from a vertex, I need to be able to draw that line to another vertex, from one vertex to another. How many times can I draw from that vertex to another vertex and create like shapes, triangles and so on? Well, I can't go from there to there. I can't go from that vertex to that vertex because that just creates a side. So I can only go from this vertex to this vertex right here. And what I do is I create two triangles, right? Two triangles. So, okay, let's do this again. What if I do a different shape? That's a 1, 2, 3, 4-sided shape, right? So let's just say if I hide that, and hide that, and hide that, hide that. Let's just do the whole thing again. Okay, so delete. Let's do a different size shape. Okay, so let's do 1, 2, 3, 4, 5. Okay, now let's see how many triangles we can create within this. So if I go from this vertex, I can go there and I can go here, right? And now I've created 1, 2, 3 triangles. So 5-sided shape, 3 triangles. Now, why is that important? So let's take a look at this. So when we go back to this, basically, we know that the angles inside a triangle add up to, so the angles inside of every triangle add up to 180. So basically, if I'm creating two triangles, then I'm going the sum of the interior angles, all these interior angles inside this shape, is just 2 times 180. Depending on how many triangles I can create, it's 2 times 180. So the sum of the interior angles of this shape, all these interior angles here, the sum of them would have to add to 360 degrees. Okay? In a pentagon, a 5-sided shape, I can make 3 triangles, right? 1, 2, 3. And so all these interior angles here would have to sum up to 3 times 180, which is 540. And hexagon, 6-sided shape will make 4 triangles. You see a pattern here. A 4-sided shape makes 2 triangles. A 5-sided shape makes 3 triangles. A 6-sided shape makes 4 triangles. A 7-sided shape makes 5. And then if you want to find out what the sum of the interior angles is going to be, all you have to do is go, how many triangles can I create times 180? So the sum of the interior angles is 900. Sum of the interior 6 times 180, and so on. So there's an actual formula here that we use for finding the interior angle of a polygon, no matter how many sides. It's going to be 2 less than the number of sides. So n, which represents the number of sides, n represents the number of sides minus 2 times 180. So that's the formula basically for finding the sum of the interior angles of a polygon. You just take 2 less than the number of sides. So if you've got an 8-sided figure, you go 8 minus 2, and then you times that by 180. And that gives you the sum of the interior angles. Now, if you happen to have a regular, right, a regular polygon where all the sides and all the angles are equal, then you can find the size of the interior angles of each one. So if I have a regular shape, all right, let's go back to my picture of regular shapes. So if this is a regular 1, 2, 3, 4, 5-sided shape, which is a pentagon, then all I have to do, how many triangles can I create? It's a 5-sided shape. I can create 3 triangles. So it's going to be n minus 2, right? Number of sides 5. So 5 minus 2, which is 3. And then that's going to be times 180. But since all the sides are equal, the other thing that I can do is, instead of just getting the sum of all the interior angles, I can figure out what each one of these interior angles is, because they're all the same size. So all I have to do is divide by how many of those angles I have. 1, 2, 3, 4, 5. I have 5 angles. So basically you're just doing that. You're taking your 3 times the 180, which is the sum of the interior angles, but then I can divide it by how many angles I have, because all the angles are the same size. So there's another formula here, and this is one that's not going to be given to you, but you need to know, and that is this one here, basically. This one, right? So you basically, the number of sides is a 5-sided shape, 5 minus 2 times 180, all right, which is 3 times 180, and then divide by how many angles or sides you have, which is 5 if it's a pentagon. If you have an octagon where you have 8 sides, you go 8 minus 2 times 180, and then divide by how many sides or angles you have, which is 8. So you use that formula to find a single angle, right? So it becomes very important. Polygons with n sides, n minus 2 times 180 is the sum of the interior angles. Very, very important. And if you have a regular polygon, then you use a formula to find each individual interior angle, which is n minus 2 times 180 divided by n, a single interior angle. Now, when you use these rules and these formulas, basically you can just say, okay, well, the reason that I found this is that properties on a polygon, or properties of a polygon, right? Or you could say properties of a pentagon if you want to be more specific, because you're dealing with a pentagon or a hexagon or an octagon, right? So you can just say properties of a pentagon, properties of a polygon. Those would be the reasons for using these formulas and so on to find interior and exterior angles. And you can do the same for an exterior angle. If you're saying that exterior angles all add to 360 and you're trying to find like a single exterior angle, you know what that's going to be. If it's an irregular polygon, then it's just 360 divided by how many sides that you have, right? Divided by 5. Or 360 divided by 6 if you have a regular hexagon. And again, you can just say properties of a hexagon or properties of a polygon.